Good day everyone, especially to my thesis advisor, Architect Madrid, and to my panel, Architect Boot and Architect Karaan. I am Cecilia D. Cunanan, 5th year BS Architecture student, and I'm going to present to you my final comprehensive design project entitled Shape-Shifting Sustainable Livelihood and Microconservation Hubs for Threatened Philippine Biodiversity Regions. My idea of an architecture of the future for our impoverished Filipino rural communities. Recap of the project brief. Given the online setup and limited resources that the pandemic has cost us, this year's thesis theme revolves around the response to realities, which allows us to choose a national or local issue and to come up with an aspirational architectural solution that is grounded on reality. While there is the tendency to be more conceptual, it must still be a responsive type of architecture that can be constructed 10 to 20 years from now. Selected national issue. From the many issues that the Philippines is facing, I chose a national concern that is often neglected but requires an urgent response: the human-driven pressures on our biodiversity and the degrading natural environment. Here, you can see 3 Philippine maps that show the increasing amount of forest loss, illegal wildlife hotspots, destructive livelihoods, and critical habitats that pushes our ecosystems to the edge of collapse. To summarize, the 5 human causes of biodiversity loss include habitat loss and destruction, overexploitation and unsustainable use of resources, pollution, climate change, and invasive alien species, all of which are direct and indirect causes of irresponsible human actions. In the past year, I have collected some of the alarming news related to illegal human interventions and the consequences they bring, especially during calamities and disasters from GMA News, ABS-CBN News, Rappler, Oceana, and etc. The architectural solution. Indeed, there is a call to address the ineffective and destructive livelihood practices and to support the insufficient conservation programs and campaigns through a linked architectural solution that can provide training and learning grounds for sustainable livelihood and microconservation. Through a three-pronged solution, the local knowledge will work hand in hand with the scientific knowledge to shift the relationship of humans with nature. This will be made possible by the provision of tech-driven, sustainable and smart livelihood skills training and on-site and climate-adaptive micro-conservation facilities that can be transported to the different threatened regions and rural communities of the country with varying ecosystems, topographic, climatic, and environmental conditions. The architectural design approach. With all these considerations, ecological architecture approaches, which include regenerative, climate responsive, and bioarchitecture, were used vis-a-vis dynamic architecture approaches, which include transformative, mobile and portable, and evolutionary adaptive architecture. Through the integration of issues, solutions, and approaches, a project execution framework was developed that will serve as the phases of the project in its future transfer. From priority assessment, site investigations, community involvement, actual training and teaching, to environmental crime monitoring and success evaluation. Selected site and analysis. Envisioned to be relocated, the project must first have its pilot site, which shall serve as the ground zero. Palawan, a biodiversity hotspot that is dubbed as the last ecological frontier of the Philippines, was established as the site of intervention because it is home to 10 of the key biodiversity protected areas of the country and is vulnerable to countless environmental crimes. From these 10 KBAs, The Malampaya Sound Protected Landscape and Seascape was chosen because of its relevance to the issues of destructive livelihoods, relevance to the site and ecosystem variations, and relevance to the communities that rely on its resources. Here is an area map showing the main parts of the sound, the local communities in yellow circles, and prospect sites in pink circles. Here are some photos of the so-called fishbowl of the Philippines and its being home to many critically endangered animals, including the Irrawaddy dolphins. Guided by several studies, a site evaluation criteria was formulated to assess the four sites that were determined, with Barangay Pancol being the most suitable. For future relocation, this series of site analysis must serve as a guide in determining the site location and the microstudies such as zoning, topographic, climatic, circulation, flood, and storm surge hazard analysis. Architectural Program. This slide shows a roadmap of the translation of the identified needs into a substantial architectural program. In order to achieve this, I began by identifying the relevant issues and stress how humans bring pressure to these and address them directly and indirectly through aspirational architecture solutions. Further, the design approaches were then integrated to serve as the foundation for all the architectural processes that will take place from here. Research-based and precedent-inspired design interventions and strategies were then applied accordingly until the core and support spaces that will make up the services of the structure to its users were generated. From this, the quality and quantitative requirements of each space were detailed through a comprehensive space programming table. Shown here are some space bubble diagrams that were first individually created and then combined to produce an overall diagrammatic representation of the zoning and relationships of spaces. Architectural Design Concept. In the process of developing the concept that will be the foundation of the project's design, form, and spatial relationships, the researcher devised several key concepts that directly and indirectly respond to the contextual issues and are in line with the dynamic and ecological design approaches that were established. From these 10 strategies, the key concepts that were complementary to each other were identified and grouped to form a recurring theme leading to the three main design concepts, which include number 1, modifiable interconnectivity, which strengthens the project's adaptability and flexibility. Second, the nature-shaped design, which will be reflected in the project's site planning and physical design features. And third, the intentional transition, which helps in integrating technological-based, sustainable, and future-proof solutions. Using the three main design concepts, the researcher explored on the links that connect these three to come up with concepts for the design of the hubs and deployable units' architectural form and structural features, which include design for disassembly or DFD, that is the project's ability to facilitate future changes, dismantlement and reassembly, and the swarm intelligence observed in nature, which mirrors the modular units that can work individually through its design space but collectively forms the hubs, which altogether produces a significant contribution to the community. Schematic design. From the main concepts that were formed, these were then interpreted into complete schematic designs by translating them architecturally and spatially into the project's macro to micro components, from site planning to massing and model studies. Here are the three main components of site planning based on the physical and local community contexts. In terms of massing and zoning, several configurations were explored based on the individual hub's need and their rationale behind. U configuration for Sustainable Livelihood Hub exhibits maximum interaction among spaces. Free-form configuration for microconservation teaching gives an explorative setup, especially for young learners. C configuration for the environmental monitoring opens wider view scope for surveillance. Linear configuration for lodging spaces gives a sense of order and uniformity, and polygonal central support allows multi-edges for connections. Lastly, hexagons of nature that feature structural stability for deployable units were useful for surface tension on water-based sites. Also included are the different roof configurations that were initially explored based on the hub's form and design concepts. Final architectural design. The discussion of the final design will start from the large-scale design down to the small-scale modular unit design. In terms of the site development plan, shown in this slide are the three main hubs, support hubs, and deployable units positioned in the two lots of the site divided by the Taytay El Nido Road. Each hub was strategically positioned based on its functions, spatial relation, privacy, and hierarchy, and are all connected to the central support hub, which shall serve as a convergence point and facilitator of seamless flow of circulation. Unpaved pedestrian paths serve as the ground access, and elevated walkways connect the upper level of the hubs in the gradually sloping site. Lodging spaces hubs were placed at the more private area of the site, and the environmental monitoring hub was placed at a more visible area. The deployable units sprawl on the extension of the site to the waters of Malampaya Sound, ready to be deployed to the inner sound, outer sound, and agricultural areas. Here is an aerial perspective of the site at the chosen ground zero. For future relocation, several configurations of the modular hubs and deployable units were formulated, each with its own advantages and disadvantages depending on the physical and environmental contexts of the target site. Here is an isometric view of the site and the entire development of the project. And here is an exterior perspective following the linear configuration, which is an advantage for sites along shorelines of municipal waters. Modular unit design. Comprising the two-level hubs are the stackable modules that use panel systems for easy disassembly and primarily made up of bamboo, steel, and concrete. From the 4x4 meter area developed an extrusion for various use such as inner corridors, additional space for storage, frame for the facade, and room for outdoor utilities. Main modular hubs. Proceeding with the main modular hubs, the first main hub is a sustainable livelihood training hub that features spaces that train local farmers and small-scale fisher folks of sustainable and smart livelihood methods applicable to their local context. Largest of the three, the hub is designed with tech-driven and conventional workshop areas, demonstrative teaching laboratories for equipment testing, and informal learning areas that are both run by people and smart technology. Aside from fishing and farming, it can also initiate skills-based and product marketing for its locals to empower other community groups. Here is an interior perspective of the workshop area and the informal learning area that initiates dialogues among community members to formulate better livelihood strategies. The second main hub is the micro-conservation teaching hub that aims at activating the local knowledge of place-based conservation by merging with the scientific knowledge to come up with the best strategies to protect the threatened flora and fauna of the country. Designed with interactive spaces, this main hub features living classrooms, VR experience areas that inform the status of Philippine biodiversity, and conservation research microlabs. Focusing conservation at a micro level, the community will be aware of the type of biological diversity of their area and partake in making concrete actions and plans to conserve it. Here is an interior perspective of the digital Biodiversity Learning Classroom, and the General Plant Research Microlab for on-site studies. As one of the main hubs, the Environmental Management Hub is a merged monitoring hub that will aid the sustainable livelihood and micro-conservation programs. Through its smart monitoring rooms that assess environmental conditions, the status of wildlife, and the surveillance system that allows locals to connect through mobile apps, the hub will be the home to local ecological management tools. This hub will help local farmers and fisher folks to protect their livelihoods from threats against illegal practices on natural resources and environmental crimes. Here is an interior perspective of the Karagatan Patrol's VIIRS monitoring hub against illegal, unregulated, and unreported fishing, and the computer tutorial room for smart fishing monitoring software tools. The support hubs. Moving forward, the project also features two support hubs that will cater to the needs of the three main hubs. First are the lodging hubs that will address the accommodation needs of the invited local and international scientists, trainers, researchers, and the like. Housekeeping spaces and necessities were also integrated to achieve and maintain user comfort. Aside from these, a two-level central support hub was designed with large areas such as the assembly hall for community gatherings, a flexible lobby, and a dining hall with indoor and outdoor options. Financial and legal assistance offices were also provided together with a clinic for health emergencies and first aid assistance. Here is an interior perspective of the shared room type for researchers that come in team, and the dining hall that serves as a common area for the invited guests and the locals. As part of the project agenda to provide on-site and hands-on learning and training, the deployable units were designed. The land-based prototype will be deployed to terrestrial-based livelihoods, whereas the water-based prototype will be deployed to aquatic-based, such as fishing communities, lakes, and municipal waters. Shown in this slide are the isometric views of the support hubs and deployable units and a site elevation of the entire project. And here is an approach perspective of the hubs with docked deployable units. Structural design. Structurally, the project is made up of bamboo, engineered in various forms for various applications, and structural lightweight steels for framing. Several typologies and panel systems were used to form the hubs, ranging from the roof that has 4 types, wall panels that has 5 types, extrusion frame that has 4 primary uses, and 5 types of floor panels depending on the space requirements. Accordingly, the beams and columns of the hubs were made from glue-laminated bamboo, the walls were a product of bamboo cross-lamination, and floor finishes also feature bamboo veneer as shown in the module assembly detail. Details of connections were also provided along with the fire-grade gypsum encapsulation and concrete column pedestal for fire and ground moisture protection respectively. Thriving in a tropical climate, a responsive dynamic facade that also uses a panel system was integrated to address the varying microclimates of each region. Designed with triangular nodes in a gliding frame for sun orientation, each panel can be reassigned and repositioned manually based on room temperature, energy, and ventilation requirements. The project innovatively used recently recognized or reused solar windows that use agricultural crop waste to harness energy from the sun by a young Filipino inventor, and shape memory polymers that respond to changes in light, heat, and humidity. Mechanical, electrical, plumbing, and sanitary systems. To ensure the project's overall sustainability and survivability, several MEPs and other building systems were used to sustain its energy and other needs. These include a built-in biodigester system that converts agricultural and human waste to gas for cooking, an HVAC system for specific spaces that require artificial ventilation, which uses lesser ducting works, solar water heaters for the lodging spaces, shower areas, and rainwater harvesting with water filtration and UV treatment tools for gray and clean water uses. The Community Project. Throughout the duration of the hub's stay in the threatened region, the community will also come up, plan, design, and build their microversion of the hubs. As the hubs will be transferred to other target sites, the community project will remain with them to ensure the continuity of the programs and oversee its implementation. Spaces of this microhub are replicas of the rooms from the main and supporting hubs, but with only the necessary areas to be considered. With community involvement, the microversion of the hubs is a reflection of architecture for the people, by the people. And with the agenda of being relocated from one threatened site to another through the concept of design for disassembly, presented on this slide are the biodiversity corridors of the Philippines and the potential flow of movement of the hubs to other target sites. The project's future application. Here is a photorealistic visualization of the hubs as they thrive and address issues in a fishing village and coastal communities, teaching smart livelihood alternatives among Philippine agricultural communities, and helping in restoring abandoned mangroves in lake communities. We often visualize a future that is fast-paced and extremely advanced in an urban city with sci-fi-like setting. But to many of our impoverished rural communities, this is not always the case. I would like to dedicate this project for one of the poorest sectors in the Philippines, our local farmers and small-scale fisher folks. For the abused natural environment and resources that shield us against disasters. For the security and resilience of our neglected rural communities. And for the future of the Filipino people. To end this presentation, please watch the walkthrough video that follows. Thank you for listening and God bless.